This is LeetCode problem 140, word break 2. It is a hard level problem, but it's not too hard. I just did 139 word break, and I'd recommend watching that if you want to follow along with this video. It's really similar to word break. We have a string S, and we want to break it into words in worddict. Cats and dog can be broken into cats and dog, or cat sand dog, and we want all the sentences that can be broken up from S into words in worddict with spaces in between the words. Hopefully that makes sense. You can reuse the word. If you cannot make a string, you would have no results. So this took a little bit of time to think about, but we have to think about how to check what word we can add to our string. I'm going to use memoization, and the memo I'm explaining it here. Of course, n is the length of the string, and memo is defaulting list, which means that if a value in the dictionary for a certain key doesn't exist, it'll default to an empty list. Anyway, what do I want? I want memo I, which will be a list, to be a list of all the sentences that can be made from the string up to index I. So, example, the string is cats and dog, and the word dict, cats and sand dog. The string from 0 to 7 is cats and. So memo 7, there's two possibilities. You can break it into cat, sand, or cats and. So memo 7, you look at the string from 0 to 7, 7 characters, and see how those 7 characters can be broken up into sentences consisting of words in word dict. There's two possibilities, so there's two entries in my list, memo 7. Memo 6 would be all the words or sentences you can make from cat san, and there's actually none. It's not possible. So memo 6 is an empty list, which is totally fine. Hopefully that makes sense of how you want to go through memo 7. When you're at memo 7, you have to think about how you can add in another word. So once I have memo 7, here's how I'd build memo 8. Or actually, yeah, memo 8, sorry. Well, it won't be memo 8, but you'll see. It'll end up being memo 10. Memo 10 right now is an empty list. So I have memo 7, cats and cat sand, made from this string. What I want to do is check every word in worddict and see if I can add it to cat sand and see if I am still following the pattern in S. So I start with cat sand. And the first word I'm going to try adding is cat. Cat, sand, cat. Does that match string S? No, doesn't work. Cat, sand, cats. No, doesn't work. Cat, sand, and. No good. Cat, sand, sand. No good. Finally, we try cat, sand, dog. This does work. This matches string S. Now we have a new possibility of memo 10, because now there are 10 characters. I have to take the new word, dog, and add it not to memo 10, not like this. I have to add dog to every string in memo 7. So memo 7 had 2 entries, memo 10 will have 2 entries, or 2 new entries, because it could have had entries before. Those 2 new entries will be memo 7, cats and, with an extra dog. And the other entry in memo 7, cat, sand, cat, sand, dog. Now memo 10 is done, and that's the last index I have to treat. So that's actually the answer to the problem. But let me code it out for you. We gotta check every word. Word dict. We need to check if that word can be added to the memo. And we need to check this. The example I was doing was for index 7. We have to do it for every index, not just 7. So what we do is we see if we can add the word onto the string from 0 to I. The way we do that is check if every character in word matches the substring from I to J, where J is the length of the word plus I. So for this example, the first word I'm checking is cat. Can we put cat onto cat sand, and will it match DOG? Well, obviously not, but to check, we're saying cat. I is 7. The length of the word cat is 3, so J will be 10. Does S from I to J, which is 7 to 10, which is DOG, match cat? No. But it will be true when we get to dog. And what do we do when it's true? We have to take every previous sentence in memo, memo I, and add that into memo J with our new word. With also a space character, because these sentences have spaces in them, just how the problem's written. So, again, when we're doing I equals 7, we're going to check every word and see if we can fit it in right after cat's and. Does cat match this? No. Does cats match this? No. Does and match this? No. Does sand match this? No. Does dog match this? It does. So, for every string in memo 7, we make a string and add it to memo 10 with an extra space DOG. This is just about right. And then at the end we return memo n. This will almost work. We're building up on our strings every time. So it's not really a recursive call, but it kind of recurs back on previous answers with the memo. What's the base case? The base case, we actually need an empty string, because the first time you hit a word you can build, like cat or cats, you have to add that onto a previous sentence, and the sentence is empty string. This will almost work, just about. Oh, whoops. I overwrote the whole memo. I only wanted this to be memo 0, because if I is 0, there's no characters before 0. Therefore, there'll be an empty string that we build on. Sorry about that. Yeah, so we almost got the answer. Cats and dog, cats and dog. These are the answers, but we have an extra space. That's because sentence starts out as an empty string. So the first word you add is added to empty string, space, word. I can fix this with a little ternary. There's different ways to do this that are more or less elegant, but I'll add on the sentence and the space if sentence is truthy, basically if it's not an empty string. Otherwise, add the word to nothing, and that should just about solve the problem with the memo. So yeah, a little tricky, but it should be okay if you understood word break 1. We're building on the previous memo. If you can add a new word like dog, then you add that word to every sentence. Where it fits. And you have one new sentence in memo 10 for every sentence in memo 7. And at the end, all the sentences for memo n, the very last entry in our memo, is the answer to the problem, because those are all the sentences that can be made with every character in S. Thanks for watching.